Okay, this is a practical guide segment on ground reaction force. Now, ground reaction forces can be complicated, the concept, the measurement, all the little ins and outs, intricacies, and that's fine, and research on ground reaction force is awesome, and it's supplying us with continuous information about ground reaction force and the different nuances of ground reaction force. But in order to really use this concept, it has to be simplified down to something you can understand, something you can apply in your teaching, your coaching, and your training, even in your therapy. Okay? So we're going to try in this segment to water down, while keeping the integrity of the information, water down or pare down the complexity to something that is practical and usable and understandable on a pretty basic level. Okay? So let's start just again with ground reaction force in general. Ground reaction force. What is ground reaction force? Ground reaction force is the ground's reaction, or really any object, it could be the wall, whatever, any surface, but when we're talking about the ground or the floor, whatever, the ground's reaction to the force you apply into it. So simply, I push into the ground with some force at some direction, and the ground pushes back with equal and opposite force, equal and opposite direction. So the ground reaction force is the force that pushes back in response to the force I'm putting into the ground. Very simple, okay? I put force in, force has magnitude and direction. The ground pushes back with the same amount of magnitude and the opposite direction. So it's a very simple, basic thing to understand. Ground reaction is the ground's reaction to you pushing into the ground or you creating force into the ground. Now, real quick, I don't want to get sidetracked, but real quick, when you say weight shift, especially in a golf swing or really any rotational pattern, swing throw pattern, when you say weight shift, weight, as we've discussed in just the basic F equals ma force segment, weight is force. So when you say weight shift, what you're talking about is force shifts, okay? And that's important because you don't have to slide back and forth to shift weight. You can just push off of one side. I can lean this way and push hard that way, and I'm still creating a weight shift or a force shift if the force on this side is greater than the force on this side. So if I start neutral and I push hard with my right foot into the ground, I'm creating a weight shift, even if I don't slide over to the right side. So that's important to understand that what we're talking about, the idea of weight shift, it really kind of has always related to this movement, but it's really related to the force application. So neutral, 50-50, we have a sort of an equal balance of force being applied. To shift weight, I can certainly shift over, right? So more of my mass is over this side, more force is going through this foot. But I can also just push hard this direction. More force is now being applied by the right side. I now have essentially a weight shift, okay? So that just goes to show you, kind of enlighten you a little bit, is weight shift doesn't necessarily mean movement. Weight shift is the force that's being applied by either side. Okay, now let's talk about ground reaction to force and what that really means, okay? So let's talk about a simple one, jumping up, okay? I'm going to use my diagram here. If I'm going to jump up, I'm going to just draw a stick figure here. Here's a torso. Here's our feet into the ground, our arms, arms, okay? If I'm going to jump up, I'm going to push down into the ground. Right? So vertical force, or what we call the normal forces, are going to be important because the force I push down this direction is going to then, the ground reaction to that is going to allow me to create joint movement and joint speeds, power, and it's going to allow me to propel myself up into the air. So if I want to jump up, I push down. If I want to jump up, I push down. Okay? The ground reaction to me pushing down is up. I use that upward force to create joint movements and body movements, power movement, and I propel myself into the air. The thing I want you to take across, to get across to you or to take home from this is, if I want to jump up, I push down, okay? So I push down into the ground to jump up. The ground reaction to my pushing down is up, and I use that upward force to propel myself through joint motions and whatnot into the air. That's pretty straightforward. I push down to jump up. All right, let's take another example here. Let's talk about walking. All right, now, here's my guy and torso. Let's draw just a stick figure, foot into the ground. Here, we're walking, arms, okay. Now, I want to move this direction. So pushing down into the ground isn't going to move me horizontally, right? It's not going to move me in this direction. Pushing down into the ground will create an interface, that's friction, so that downward force is important from a frictional perspective. But in order to move this way, what force is going to be important? If this is the ground, the force that I'm pushing horizontally backward is going to help me go forward. Just like if I push down, I jump up because the ground reaction is up. If I push backward, the ground reaction is forward. I use that force to create joint movement and whatnot, but to go forward. So I push back to go forward. The ground reaction pushes forward, and that's what I use to go forward. In this case, the downward force is predominantly creating friction. So the downward force creates a solid interface between the shoe or the foot and the surface you're standing on. So I'm really using the horizontal force, what we call shear force, to move myself forward. Does that make sense? So you've got downward force to jump up. You've got horizontal force to move forward. Okay? Now, let's get to the golf swing or any rotational pattern, any swing throw type of pattern. Okay? Let's just draw our stick figure here, our torso. Let's have them holding the club to begin here at address, and let's put our feet, just draw our feet. Okay? Here's our surface. Now, here's the key to a rotational type pattern. I have need for downward force as well as rotational force, or shear force, horizontal force. In the golf swing, a lot like walking, the downward force is predominantly, not exclusively, but predominantly used to create the interface. So I'm going to push down into the ground. Some portion of that's vertical, some portion of that's horizontal. The vertical portion, for the most part, is creating an interface or friction so that I have a solid connection to the ground. Okay, and we can talk about the nuances of how people kind of rise up and squat down, things like that. But what that's actually doing and the timing of that, we're not going to get into that in this discussion. But let's just say, just for simplicity's sake, the downward force is for the most part creating friction. It's pushing our foot into the ground, creating a good contact with the ground, and we're going to rely very heavily on the horizontal forces for the most part to create the movements that we want in the swing pattern. Okay? So that's our idea in golf. So now let's take a look at a swing pattern from the top down. So now we're going to look at the feet. Okay, this is our right foot. Let's just we'll draw it down right, and this is our left foot. This is our left. So we're swinging or striking a ball, a golf ball, let's say this direction. Okay, so how does this whole thing work? Well, now the downward force that we're pressing into the ground with is creating, for the most part, an interface, friction, that creating a good solid interaction between the surface of the foot and the surface that we're standing on. Okay. Now, what's going on? Let's draw our pelvis in here as just a sort of a bar or a beam. Okay. Now, let's move into transition and downswing. Let's not worry about the backswing right now. It's all the same. But let's get into the sort of the meat and potatoes of this thing. As we're already into our backswing, we're rotating this direction. We now want to stop the backswing rotation and we want to start the downswing rotation. Okay? And to do that, we're going to break the rotation that's going this way, shifting weight both from rear foot to front foot, or force as a function of shifting force is a function of creating a linear momentum that we can then turn into rotation. And again, we're not going to get sidetracked with all these nuances. We can create several secondary segments on that because they're a little bit complicated. I don't want to muddy the waters here. But let's talk about what's going on. So in essence, simplify it down to something we can really understand and use. In essence, what we're doing is, to move this direction to initiate the downswing, we've got to push this way, along the surface of the ground, the horizontal force. To create a rotation this way, or a movement of the pelvis this way, we've got to push against the ground that way. Okay? So we've got horizontal forces going this way, horizontal forces going that way. The resultant between the two, and it varies, because it gets, sometimes as we transition, these forces will get bigger, and these forces get bigger, so it's not a static set number. It's constantly moving and dynamically changing. But we're just taking a snapshot of it right now. We're going to get a ground reaction that looks something like that. Or a force into the ground, the resultant force into the ground looks something like that. Okay? Now, let's use green as our ground reaction. The reaction to that is equal and opposite, and it's translated through the joints of the ankle, the knee, the hip, into the pelvis to push on the pelvis in this direction, okay? Part of that force is moving us laterally. Part of that force is creating a rotation at the pelvis. Now, as we move laterally, we now what? Push with our foot this direction and this direction. This direction to brace or start to slow down the lateral movement. This direction to aid in the rotation. So what happens? Now we're pushing this direction with our foot. The ground is pushing back with equal and opposite force in here. So what we've done is we've created essentially a force couple or a torque, and that torque is essentially creating a rotation of the pelvis. At the same time, it's moving that pelvis or moving that center of mass forward a little bit. So we get this relationship of both rotation as well as some lateral or linear type movement. Now, depending on the style of swing, how you're employing this stuff, you can vary how much lateral movement you get versus how much rotation and all that kind of stuff. And that's up to you to decide how you want to apply this information. But this is what you're manipulating when you're manipulating ground reaction force. So your connection to the ground, your utilization of forces, and your ability to use the ground reaction to applied force to create the first most crucial movement to the golf swing or any swing throw pattern, and that is the rotational movement of the pelvis, or essentially kind of the hips, if you want to call it, but essentially the pelvis as we rotate. So if I can just show you real quick, as I take the club back and I'm rotating, I now need to break this movement, and I need to start to move some forward. Even if I'm already kind of leaning, I'm going to still move a little bit. So regardless of the style, these principles apply. You're just manipulating the context a little bit, or you're varying the application a little bit, but they're always going to be the same stuff. As I do that and I start to transition with my lower body, I start to push this way, and the resultant is essentially this way. Okay? And then as I start to press forward into that lead side, I'm pushing this way and this way. The resultant is this way. So I'm essentially creating a resultant that's kind of like this. Okay? Lead foot's kind of like this. Right now, again, this is just a snapshot in time. It varies around as we move. Okay? But this is essentially what we're doing. And as we do this, the ground pushes back and creates that rotation. So it's not only moving me forward, but it's creating a rotation at the pelvis. That's absolutely crucial to developing the kinetic link or the kinematic sequence or segmental summation, whatever variation of that name you want to use. But the sequence of moving from proximal to distal to create distal and speed is crucial, is heavily dependent on your ability to create a movement at the lower body from your ability to create ground reaction. So, ground reaction force, pretty straightforward stuff if we simplify it down to some of the key components. This shear or this horizontal force and our resultant pressures creating ground reaction that essentially create a force couple that not only rotate the pelvis but move the pelvis linearly or laterally, however you want to define that, some degree. Okay? And it's that lateral movement or linear movement that's also creating some of the momentum that we're turning into speed. So we'll talk about that in another segment. But this is the basics to ground reaction force. I think it's pretty straightforward if you think about it, and if you understand the idea that weight shift is really force application, and what you're really trying to do here is to create a force couple or a torque that not only moves you in a linear fashion, but in a rotational fashion. You want to blend linear and rotational together to create the optimal movement. That's what we're talking about when we're talking about ground reaction.